Welcome everyone. This is the video tutorial on how to simulate circuit in Quartus software. So after you execute Quartus, you land here. So the starting screen, empty, no project. So let's start with creating a project. So you go to File, New Project Wizard. Here you just click Next. Then now it's time to choose the location. Remember that location path of the project cannot contain spaces or special characters. This is very important. So I will create folder project 05, go into it, select folder. That's the best way to go. Name of the project, I will name it CPE100L. Then I go to next. Here you don't change anything. Next. Here is the screen to choose the device. For just the simulation, you don't need to do anything here. You just click next. But once we are here, I'll show you how we will be doing that starting from the lab when we start to use hardware. So your D0 CV board has Cyclone 5, so you choose Cyclone 5 here, and then you have long list of variants. It's the best way to use name filter. I already copied and paste the chip that I have on my board. Always double check if the symbol on the chip, on the actual hardware chip, is the same, or just enter the symbol in this name filter field. And you can see that it narrowed down just to one chip. Chip selection has no impact on the simulation. Then you click next. Here, make sure that in the simulation you choose model sim Altera and leave everything as it is and click finish. Okay, so we created our new project. And now it's time to add files because our project is now empty. So let's go to File, New, and choose Block Diagram Schematic File. So you can see that right now we have space to add components to our design. Okay, so to add components, here you have the gate symbol, which is symbol tool, and when you click it, then you have this window, and I want to create a circuit that will have two gates. So first gate will be AND gate with two inputs. So I'm typing in AND 2, right? Because I want AND gate with two inputs, because we have other types of AND, like AND 3, then it has 3 inputs, and 4, it has 4 inputs, right? But I want to have AND with 2, and then just click OK and just place it on your workspace somewhere. So this is my AND gate. Now I would like to add XOR gate. So again, I go to the symbol tool and I type in XOR. I don't need to type XOR 2 or anything else because XOR gate has always only 2 inputs, and I will place it somewhere here, maybe. Okay, of course I can move. Okay, so I have 2 gates. I want to connect them right now. So if you hover the mouse, just like that, then you can see the connection is done. You can observe when you move the gate, then this connection also moves. All right, so I have 2 gates. Now what I need to add are inputs and output. So again, I go to the symbol tool and I type input, and I have input symbol here. Okay, so first, second, and third input, and now outputs, again, symbol tool, output, because we have just one, it will be just right below the input. Okay, so this is my circuit. What I would like to change here, I don't want pin name, pin name, pin name. I want to name my inputs and outputs. So if you double click, then I can just enter A. You can double click outside of the letters, then pin properties window will appear. It will have the same effect, it's just the other way to rename the pin, so this will be B. And this one will be C, so I have A, B and C inputs, and output will be Y. Okay, Y. Okay, so I have my circuit right now. So now time to save. Please remember that your first or main file, main schematic, it needs to have the same name exactly as your project, because this is your like top entity in the project. So if my project is named CP100L, then my main circuit also needs to have the same name. So just leave it as it is and save. Okay. So circuit is ready. Now it's time to simulate the circuit. But right now, this is the form that is clear for people, for humans, but not for computers. This visual, good for us. We need to compile, right? So we need to translate this visual form into digital form. So you go to processing, start compilation. And now we wait. You can see that this is the output box. There are some warnings that are indicated in blue color. Please disregard all the warnings. We are okay with them in this class. Green text indicates good messages. And yes, blue warnings and red are errors. So what we want to have here is that the compilation ends with 0 errors. And you can see the progress right in here. Typically we need to wait some time until this is done. So we are waiting. Every time you modify the circuit, you have to recompile before you attempt the simulation again. Okay, so I got the message, full compilation was successful, 14 warnings, that's okay. Okay, so now I'm ready to add simulation component. So I go to File, New, and from this list you need to choose University Program VWF. Okay, and you will get this window. So what is that? So this is the timeline. You can see that the time is here, right? So we start with 0, then 10 nanoseconds, 20 nanoseconds, 30, and so on. So these are our time periods. For each time period, we can define states of the inputs. So we need to add inputs and outputs. So you right-click here on this area and choose Insert Node or Bus. Then Node Finder. Make sure that Filter is set to Pins All, and then click List. And you can see that all my inputs ABC and output Y appeared here on the left in the box that lists all the nodes that were found, and selected nodes, I want to add all of them. In more complicated circuits, maybe not necessarily you want to add all inputs, outputs. In this case, I'm adding everything, so I will use this. Okay, and they are all selected, and click OK. And what you can see here is that A, B, and C are set to 0 all the time. Y is undetermined because we haven't executed the simulation yet. So we want to test our circuit with all the combinations of the inputs, right? So, sorry, how this will work. So maybe I can start the whiteboard real quick. Okay, so truth table, we have A, B, C inputs and Y is output, right? So how we can do that? So we can have like this 0, 0, 0, 0, 1, 1, 1, 1. So to cover all the combinations 0, 0, 1, 1, 0, 0, 1, 1, and C will change 0, 1, 0, 1, 0, 1, 0, 1. So this gives me all the combinations, right? And you can see that this number in decimal is 0, this number in decimal is 1, this number in decimal is 2, and so on. So these are all the combinations that are possible on 3 bits. So from 0 decimal to 7 decimal, correct? So what is the purpose of the simulation is that Quartus will give me all the values here that I don't know right now. Of course, I could analyze my circuit and I could calculate by hand all these values. In this case, it can be done. But imagine that we have 4 inputs, 5 inputs, then number of combinations is really really high. So that's why we use the simulation. So we need to enter all these combinations. So we can see, let's start with A. So A is 0 for first 4 time periods, and then is 1 for next 4 time periods. So 1, 2, 3, 4, and then I can select 1, 2, 3, and 4. You can see I selected 4 of them, and here you have force 0, force 1, force low, force high. So I will click force high, and you can see that in the time period between 40 nanoseconds and 80 nanoseconds, value of A will be 1. In the time period from 0 till 40 nanoseconds, value of A will be 0. Now B. B changes 0, 0, 1, 1, 0, 0, 1, 1. Okay, 0, 0, 1, 1, 0, 0, 1, 1. Okay, so now I have B covered and C changes 0, 1, 0, 1, 0, 1, and so on. Okay, so 0, 1, 0, 1, 0, 1, 0, 1. So this gives me all the combinations of the inputs, and I will receive all the values for the output. All right, so my simulation is now programmed, is set up. So now we need to save the file, keep the default name, and go to simulation and choose run functional simulation. And now we are waiting. We have the message box. So we are waiting for the results, and here we got it. And you can see that right now Quartus gave me the results, because Y is now visible, determined. So the results will be 0, 1, 0, 1. So 0, 1, 0, 1. 0, 1, 1, 0. 0, 1, 1, 0. And that's it. So this is the simulation waveform that you will have to place in the post-lab or pre-lab. So just do the screenshot, and this is your result of your simulation. That's how you do the simplest simulation in Quartus.